Hmm.
I see. So here's the example for isentropic process. So 1 pound of an ideal gas undergoes an isentropic process from 95.3 psig and a volume of 0.6 cubic feet to a final volume of 3.6 cubic feet. If CT is equivalent to 0.124 and CD is equivalent to 0.093 BTU per pound runtime. So what are letter A, temperature 2, letter B, the final pressure or pressure 2, letter C, the change in enthalpy, and D, the Workman rule. Okay. So given tayo ng isentropic process, so that is adiabatic or that is constant entropy. Talagay natin dito. Okay, with this, meron tayo ng relation na PV raised to K is constant. So let's rewrite the different relations. So for our pressure, meaning ito ganito. So P1 V1 raised to K equivalent to P2 V2 raised to K. So yung volumes lang natin ang affected doon sa exponent na specific heat ratio. Okay, so sa the relationship naman, so this is, and ito na ang isa. So this is the relation in pressure to volume. So another, rewrite ko lang. We have here T2 all over T1. Right, rin naman natin. T1 all over T2. That is equivalent to V2 over V1 parenthesis K minus 1. And for temperature to pressure naman, we have here P1 all over P2 raised to K minus 1 all over K. In this given problem, required tayo hanapin si T2, P2, delta H and or non-flow or WN. So, determine mo natin yung mga binigay na properties. So, at point 1, meron tayong pressure dyan. So, ayan, P1. Dati, 95.3. SIG. Meron tayong volume 1. 0.6 cubic feet. Given na tayo ng final volume natin, that is P2 at 3.6 cubic feet. And our specific heats, we have specific heat under constant pressure na 0.124 and CV, specific heat under constant volume na 0.093. Both are in BTU per pound mass na unfied. Okay, so what's next? Let's try to get T2. So to get T2, given tayo ng ito, V2 and V1. So gamit itong formula ko to. So first, wala tayong K, so let's solve for K muna. So as we recall, K is equivalent to Cp over Cp. So this will become unitless since same sila ng unit. So i-divide lang natin yan. That is 0.124 all over 0.093. Okay, labas yung mga calculators. And then, okay, solve ang ating K.
1.3333.
Okay, so dire-diretso no? 1.333333, ganun ba?
Yes, sir.
Okay, so in this case, para yung answers natin is accurate and precise, caltech tayo, no? So, i-AAC nyo muna yung calculator and then answer, shift store, or shift RCL, and then pili ka ng variables from A to F. Para pag i-multiply nyo or i-exponent nyo si K in a problem or in a formula given, more accurate siya. Alam mo na yun, no? Yung shift. Tapos plus RCL. Pipili kayo doon sa fourth row ata. Yung may mga variables na A, B, C, D hanggang F. Tapos i-recall nyo na lang yung case. So in this case, we will use the temperature to volume relationship. So we can say, we can solve for this muna, the volume ratio. And then we can just simply divide it sa ating T1. Kumbaga ganyan. Pinagpalit lang natin sila. So, cross multiply natin si dito papuntang right hand side. So, numerator yan. Then, cross multiply natin itong whole equation na ito. Whole right side equation, right hand side equation. Papuntang denominator ni D1. So, let's try to solve this first. T1 natin. Hindi ba given si T1? So we can solve P1 first via PVMRT and ideal gas law. So we all know PVMRT. So we can solve mass as P1 V1 all over R P1. Given tayo ng pressure natin. That is 95.3. 1 force per inch squared. Multiplied by 12 inches 1 feet squared multiplied by our volume 1, that is 0.6. Aling ginagawa ko. Temperature para to, sorry. This is MR. Papagitin lang natin. .6 cubic feet. All over R natin. Hindi given ng R pero given tayo ng CP and CV, and we all know the formula for R. From CP is equivalent to CP plus R, we can get R as CP minus CV. So, direkta na lang natin dito sa baba. So that is 0.214 minus 0.093. BTU per pound mass. Okay. Multiplied by our mass given yan 1 pound. So 1 mass. So by unit analysis, pala pwede ito. Kailangan natin i-multiply pa yung denominator into BTU per pound force. Para makansel si BTU. That is multiplied by 778 foot-pound force per 1 BTU. Okay. So cancel si BTU. All mass. All force dito. Inches squared dito. And then mag-merge itong feet sa feet squared para makasal itong cubic feet. Litera is Rankine from the denominator. So, mapupunta yan sa taas. Okay. So, pakisolve sa P1 muna. Sabihin ko kayo mag-solve. So, for T1, we have 95.3. Maganda pag mag-solve ko is i-fraction nyo na kaagad yung nasa third bottom below the upper left corner about button. Fraction, then that 95.3 sa numerator. Multiplied by 144.6. Divided by 778 multiplied by 23.124 minus 0.0. So we can get a temperature 1 for 341. .4014. So negative reaching negative Fahrenheit yung ating temperature. That's Rankine na. Okay, so how do we get T2 again? Yan. So basically, i-resolve natin yung volume ratio raised to K minus 1. So give tayo ng K dito. Okay, next page tayo. So V2 over V1 raised to K minus 1. So given tayo ng V2 and V1, V2 is 3.6 cubic feet. V1 natin is 0.6 cubic feet. Raised to K natin is 1.133, or let's say that is at your variable A. Ilang value nito? Answer ko.
$1.8170.
Okay, sige. So sa mga hindi nagka-calculator, ganito yung itsura nung pwede yung i-input. So that is 1 point. Okay, ulit nga. Yung na-solve nyo kung tama.
8170, sir.
Okay. 1.8171. This is the ratio on volume. So yung alpha A dito, that is yung 1.333 na nakuha nyo. Anyway. So after getting our volume ratio naman, so i-divide na natin si T1 with this value. So that is, therefore T2 natin equivalent to T1 all over 1.8171. So on. May for solving calculator, laging wag niyong i-assume or wag niyong putulin sa sa akin is for decimal. Wag niyong putulin sa for decimal, laging either you can set it as the answer na variable or pwede niyong i-shift store muna sa ibang variable, then recall nyo na lang. So T1 natin 341.4014. Okay. So ilan si T2 natin? So 187.8804. Paras pa tayo. 187.8804. Okay. So we can say that T2 natin, small t, is equivalent to, kung minus 460 natin yan, that is negative 27. Fahrenheit. So next is P2 naman. P2. We can get P2 with this relation of temperature to pressure. So rewrite natin. We have P1 all over T2 equivalent to P1 all over P2 is to K minus 1 all over K. So given tayo T1 and T2 and P1 is also given. Okay, so in this matter naman, we will parang i-square natin siya into K minus 1 over T. Okay, so try, i-solve muna natin si 1.333 minus 1 all over 1.333. So that is alpha A minus 1 all over alpha A. So that's 1/4. So magkakaroon tayo ng exponent dito na parang 1/4. Nagiging T1 all over T2 is equivalent to T1 all over T2 raised to 0.25 or let's say na raised to 1/4. Therefore, we can rewrite this equation. Pwede nyo i-shift solve yan, pero sobrang tagal niyan. So T1 all over T2 is equivalent to 4th root of P1 all over P2. Parang ganyan. So we can simply work yan, cancel. So therefore, magiging, can say na P2 equivalent to P1 raised to T1 over T2 raised to 4. Okay. So let's solve. We have P1 sa 95.3 PSI G all over. So T1 341 .410 4014 divided by 187 22 natin. And then ito, pero nakarun ko yun kasi. 187.8804. So that is the same lang din para dito. Forgot about it. So our T1 all over T2 is just the same as this ratio, in which that is 1.187. 1. But raised to 4 natin to. So 495.3 divided by this one, we can get at least 8.7409 PSIA or PSIG pala. That's your pressure. So very low. Then next, sa C naman, matrabaho kay isentropic kasi yung relations na ito. Pahirapan hanapin yung mga ibang properties. C and D, change in enthalpy and work and flow. So change in enthalpy tayo. Enthalpy is always MCP delta T. So given tayo ng mass, that is 1 pound mass. CP natin, that is 0.124 PT per pound mass. Mankind. And delta T natin, this is the mass 1 pound. And then we have the CP here, 3.214. Nakalagay na dito. Dito natin is 187.8804. Minus our T1, that is 341.4014. Nakaran kayo niyan. So obviously, mag-negative yung ating delta heat or delta enthalpy. So ilan yan? Please solve.
Negative 19.0366.
Negative 19.
0366.
Okay. BTU. And then for letter D, so binigay ko last online class yung mga formulas for isentropic. And for work and flow, for isentropic, that is P2 V2 minus P1 V1 over 1 minus A. But since hindi natin, given na pala lahat. So we can simply substitute the values here. So P2 natin, solve natin yan as, sana yun eh? Ito, 8.7409. Inches squared yan. So, 144 na lang natin. Inches squared. Per feet squared. Multiplied by V2 natin. Ano natin, 3.6. Tuloy na lang natin to. Minus P1, B1. Given tayo ng pressure 1 at 95.3. Inches squared multiplied by 144. Inches squared per feet squared. Multiplied by our volume 1, that is 0.6 cubic feet. All of this is all over 1 minus 1.33333. And then this is our workman flow. Hindi, pala. Since ang final natin dito, magiging final unit natin dito is foot-pound force feet. So, kailangan pa pala natin to i-multiply sa 1 BTU all over 778 foot-pound force. Ang sabihan. So, cancel, magiging fit lang tong dalawa. Okay, na-cancel to lang din. So, ilan ang ating workman flow? Ilan? 1 po. Ilan?
14.2781, sir.
14.2781. BTU. Ayun lang. So, kailangan lang aralin yung ating formulas and the relationship of kung ano yung constant. Okay, so we expect at least on Friday regarding regarding processes, thermodynamic processes. Siguro tatlong problem. So merong isang process na hindi ma-quiz or pwede rin tigi isang problem. Depende pa. Okay. So let's go to thermodynamic cycles naman. Na-screenshot niyo ba yung first slide for notes? Balik ko. Okay, screenshot niyo muna. Next page. And the last page. Okay. Okay, so let's go to thermodynamic cycles naman. Okay. So first is binigay sa atin is Carnot cycle. Okay. So Carnot cycle is the most efficient thermodynamic cycle. So it is consisted of two isothermal and two isentropic processes. So for Carnot, ang ating PV and TS here is like that. Let's draw the PV and TS diagram. Unahin natin si TS. So this is 0.1. This is 0.2. This is isothermal process. 0.1 to 0.2 is isothermal process. 0.2 to 0.3 is isentropic. 0.3 to 0.4 is isothermal again. And then the 0.4 to 0.1 process is isoentropic. So makikita nyo naman na pag 0.1 to 0.2 isothermal kasi the change is from the horizontal lang. So constant temperature yan. Ganon din sa 2 to 3, constant entropy. Since horizontal lang ang ay vertically lang change. And so on. So for our PV naman, goes like this. So let's say this is our 0.1. So this is our 0.4 na lang. Okay, let's see here. So from here, it's our 0.1. There's a adiabatic expansion here. This 0.2. And then from 0.2 to 0.3, we have an isentropic. An isothermal expansion pala from 0.1 to 0.2. And then adiabatic compression from 0.2 to 0.3. So, punta yan dito. An isothermal compression from 0.3 to 0.3 to 0.4. And then lastly is isentropic expansion naman from 0.4 to 0.1. So i-base lang natin siya sa ating TS diagram. So from 0.1 to 0.2, that is temperature constant or isothermal. Since pataas yung volume natin, pa-right, that is isothermal expansion. And lagay ko yung arrowheads para kinalilito. Then from 0.2 to 3, gaya dito sa TS natin, that is isentropic. And since nagre-retract ang ating volume, obviously that is compression. So isentropic compression, ang ating 0.2 to 3. From 0.3 to 4 naman, that is constant temperature or isothermal compression pa rin. And then from 0.4 to 1, we have isentropic expansion. And dito na lang dito. 150. Eight to 4. Okay. This is the summary of the PV and phase diagram. So recall natin yung pinakauna kong sinabi, yung kumbaga first law. Diba? Kasi we have a body here. So lahat is QA. So lahat ng papasok na heat is lalabas lang din, diba? So pwedeng QR, pwede rin ma-convert yan in work. Work done by a system. So in relation yan to engines, ganyan. So it is a power generating equipment. So lahat ng work and lahat ng heat na papasok is hindi 100% na makakonvert into useful work lagi. Meron tayong losses and meron tayong kumbaga ito heat loss. Meron tayong mga work na kailangang gamitin for the system. And then after that lang tayo makaproduce ng work done by the system or yung na-generate nating power. So kasi meron tayong dalawang klase na energy. So we have available energy. Meron tayong dyan. Available energy. Meron tayong available. Available energy is yung part ng heat na makakonvert natin sa mechanical work. Ito na dito. Part of yes. Can be converted to mechanical. Ipabaliktaran lang yan. Available energy. This is the remainder. Okay, so kumbaga pag i-relate natin sa human body ang engine. So yung heat added or QA, heat na papasok sa atin is the fuel. So yun yung pagkain. So it is converted into available energy, yung movements natin, yung pag-push natin, paglalakad natin, pag-iisip natin, those are available energy. Sa engine naman, yun yung, kumbaga, pag-combust is pag-andar ng, kasi for an car, automobile, yun yung pagpa-power up niya ng AC, yan, so, pag-andar mismo. And unavailable energy naman, these are the, kumbaga, remainder, yun yung mga excess na energy. Kumbaga sa human body, yan yung mga pawis natin, yung mga kulangot natin sa iba, yung ebak natin, ganun. Sa ano naman sa car, those are the, yung ano mismo, yung usok, kumbaga. So, yung mga excess or flue gases. And then, yung mga, kumbaga sa radiator, sa yung pag-heat up ng other parts of the engine. Napupunta sa, ayun, sa water, ano, cooling system. Those are the rejected heat. Kumbaga. So next is, ano pa ba? Let's relate na lang di ano. Ako ba nilagay yung 1 dito? For to. Let's try to relate the PV diagram sa piston cylinder. So ideally, Carnot is the most efficient, pero ideally lang, wala pang actual na Carnot engine since it is too efficient and almost impossible to manufacture. So, hindi ko alam mo yan kung meron na, pero wala pang Carnot engine. Ano lang po ang gawin sa dyan. Okay, so let's say we have here 0.1. Then we have here piston cylinder assembly. 0.1 natin is yung end ng piston. Meron tayong rod dito. So at 0.1, okay, let's start here dito sa, let's say we have here the 0.1 natin. So pag 1 to 2, let's say this is R2. That is isentropic compression, isentropic expansion. So lalaki yung, let's say for this, yan. Lalaki yung volume natin, parang papakawalan natin. Nakalinya yan dito. Yan dito. Aatras si piston rod natin. Lalaki yung volume dito. Let's say this is the forecast, this is the log. The next is, ito naman, isothermal expansion. Nag-further expand pa yung piston. Parang nag-ipon pa lang kasi siya dito ng mixture of gas and air mixture. And then there is our, kumbaga i-compress niya na yung air and gas. Haluin niya na yan. Mag-retract ulit kasi dito yung ating piston. Tapos dito na parang mag-explode or mag-combust ito sa part na to. So pag combustion, atras ulit yan into 0.2, then 0.3. Then mag-input ulit tayo ng fuel and air supply and so on. Anyway, ko lang into the piston cylinder movement, yung PV relation niya. So for formulas of a Carnot cycle, so mainly ang ating susolve lang dito is QA or heat added. Ang ating QR or heat rejected. Then our work net. So hindi na ito yung PDV. Next is our cycle efficiency. Our next is mean effective pressure. So for our QA, so from before, sa process kasi, diba, that this heat added is equivalent to delta U plus work net flow. So for cycle naman, so for Carnot cycle, nag-vary din ito kung anong cycle meron tayo. Ang ating heat added here is T1 multiplied by S1 minus S4. Entropy 1 minus entropy 4. So, madaling sabi, every process natin, so let's say for example, yung 0.1 here, kailangan natin kunin yung different properties niya like temperature, volume, pressure, and so on. And then makukuha natin yung delta S niya. Let's say for example, here to here is isentropic process. Yun, makukuha natin yung entropy with that. And then for QR naman, ang ating general formula for QR, that is, dalawa kasi, meron tayo T2 times S2 times S3. Or T2 multiplied by S1, S4. Ito lang din. Work net natin, work net is always QA minus QR. And then for cycle efficiency, that naman, or this is denoted as E is for cycles, yung magandang cycles laging work net all over QA. So since work net is equivalent to, so kung ano itong negative pressure. So may shortcut kasi. So since work net is equivalent to QA minus QR all over QA, we can say that efficiency can be calculated as 1. Ito, parang Na-cancel lang niya naging 1 all over QR minus QR all over QA. And also, or pwede rin natin sabihin efficiency, cycle efficiency. It's equivalent to, since worknet natin is yung worknet natin is or QA over QR natin, that is T1 raised to multiple by S1 minus S4 minus QR natin, that is, let's say this one, to T2 S1 minus S4 all over QA natin, so that is T1 minus S, ay, multiplied by S1 which is S1. Technically, pwede natin i-cancel lahat ng entropy. So, since denominator natin is multiplied by S1 minus S4. So, pwede natin i-cancel in this term, yung S1 minus S4, in this term, yung S1 minus S4, leaving us with another formula for efficiency as T1 minus T2 all over T1. Screenshot muna. We have heat to temperature relations. Parang ganito. UR. This is not applicable to other cycles, but for Carnot, this is applicable. This relation between heat and temperature. And lastly, our sample and our MEP or mean effective pressure. MEP. Or some books, ganyan ang paglagay nila. Mean effective pressure. Pressure MP. So for mean effective pressure naman, this is just work all over volume displaced. Work net all over the volume displaced. Or simply QA minus QR all over, I think that is V3 minus V1. Yung pinakamalayo sa pinakamalapit. Ito. The distance between this volume and then this volume. Okay, ano lang. Pero mas maganda pag memorize mo. Okay, all over V. Okay, screenshot na lang yung mga important formulas. Yung notebooks nyo pala Okay, ready. And then, please make it before tests para nag-review kayo habang nagsusulat, habang nag-rewrite. Are there questions for the Carnot cycle before we solve problems? So, wala ka. Okay. Wait lang. Okay, so before proceed to the problem, meron pa tayong nakalimutan. The expansion ratio and compression ratio. For expansion ratio, this is equivalent to the volume at the end of compression over the volume at the beginning of expansion. So, then for compression ratio naman, this is the volume at the beginning of compression over the volume at the end of Yes, for example, you have here EVNTS. Say, yung kanina lang din. Yung paano ba yung 1, 2, 3, 4. So, kunwari pag ganito yung ating cycle. So, for isothermal expansion natin, this is SC, this is DC. This is another SC. Sa gitna ito is DC. So, we have two kinds of expansion, isothermal and isentropic. Ang isothermal expansion natin is from 4 to 1. Okay. So, isothermal expansion. Ratio, end of expansion all over the volume at the beginning of expansion. So in this case, the end of expansion is at 0.1. So that is volume 1 all over volume 4. So mag-vary to depende sa kung saan nyo umpisahan nyo cycle nyo. Kung dito nyo umpisahan yung cycle nyo, so dito magiging 1, 2, 3, 4. So, magiging ang isothermal expansion nyo in that case is V3 all over V4. Since magiging dito yung 0.3 mo. Or V4 all over V3. Since magiging dito yung V3 mo and magiging dito yung V4 mo. So, at the end of expansion, that is V4 over V3. So, in this case naman, sa ating EVTS diagram ng Carnot, dito is the 0.1 is the end of expansion. And 0.4 ang beginning of expansion. So another expansion ratio is isentropic expansion. Ratio. Meron tayong R or isentropic expansion ratio, isothermal expansion ratio. The R, variable R represents ratio for the expansion and compression. So for isentropic expansion ratio naman, dito naman, isentropic expansion is around 0.3 to 4. This is your expansion. You can see low point of volume here. Nag-expand siya in hanggang 0.4. So for this, expansion ratio is volume at the end of expansion. So that is V for volume for all over the volume at the beginning of the expansion. So that is V3. And this is your isentropic expansion naman. And then tuloy lang natin for compression ratio. So ratio. Ngayon natin yung isothermal compression. For isothermal, dito yan. So for compression ratio, that is volume at the beginning of compression. So this is V2 all over the volume at the end of the compression. So V3. And for the compression ratio of isentropic, so nandito yan sa 1 to 2. Isentropic compression. So beginning of compression, that is V1 all over the volume at the end of compression, that is V2. So meron din tayo tinatawag na overall ratio, overall expansion ratio. So technically, that is the volume at the end of expansion all over the volume at the beginning of expansion. So since ang total volume na in-expand natin is from 0.3 to 0.1. So diretso yan na expansion. Ang volume at the expansion is 0.1. So that is V1 all over the volume at the beginning of the expansion. So that is V3, the lowest volume. Ayun nga, nag-vary din yan kung saan point ka nag-start ng cycle. So for overall expansion ratio in this type or in this PVTS, that is V1 all over V3, and overall compression naman compression. So that is the volume at the beginning of compression. So that is 0.1 all over the volume at the end of compression. That is 0.3. Okay. Ganun lang din. So technically, it's just the same. Let's proceed to the problem. Hindi ko i-box yung mga ito kasi nga it can vary depending on where you start your cycle, the PVTS. So ito na lang tandaan niyo. Itong dalawa. Expansion ratio and compression ratio. Okay. So let's solve this problem. Extend tayong konti. So a Carnot power cycle operates on 2-pound mass of air between the limits of 70 degree Fahrenheit and 500 degree Fahrenheit. So the pressure at the beginning of isothermal expansion is 400 psia, and at the end of isothermal expansion is 185 psig. Determine the volume at the end of isothermal compression. B, change in entropy during an isothermal process. C, the heat added. D, the heat rejected. And E is the work net. Lastly is the mean effective threshold. Okay. So first we will draw the masyadong matrabaho ang cycle kasi combination of two or more processes. So dito sa Carnot cycle, this is four processes tayo dito. So first and foremost, for cycles, lagi natin ito-drawing muna yung PV and TS diagram. The processes, maski hindi. Kasi 2 points lang naman yan. Two phase, or 2 states, or 2 points lang naman yan. So for Carnot, mas magandang diskarte is unahin natin ang TS since dalawang constants dito. 2 isothermal and 2 isentropic. So let's have this as point 1 again. Point 2, 3, and point 4. The side of it is at point 1. So this is 2. So the PV diagram goes like this. So at point 1, compressing at point 2, compressing at point 3, expanding at point 4. Curve yan. Walang straight. Para mas madali, i-identify nyo na sa PV diagram nyo if the process is PS or S, TC or SC. So at point 1 to 2, this is isentropic since si temperature ang nagbago. So SC natin dito. Point 2, 3, this is temperature constant, isothermal. Point 3 to 4, this is isentropic again, so SC. And then dito sa 4 to 1 is temperature constant ulit. So meron tayong mga given natin. Given muna. So mass natin is given at 2 pounds of air. So meron din tayo dito. Limits. When we say limits, kasi this is the highest and lowest point. So in this case, we have our lower limit as 70. So at lower limit, this is 0.1, obviously. So T1 is 70 degrees Fahrenheit. But from your TS diagram, temperature 1 is equivalent to temperature 4 Kelvin. This is what makes this cycle most efficient kasi hindi ito lang, mag-vary lang yung temperature mo into dalawang points lang. Then for T3 naman, that is your upper limit, that's 500 degree Fahrenheit. And which is equivalent to T2 lang din, as you can see in the diagram. What else are given? Given din tayo ng pressure 1. Pressure at the beginning of isothermal expansion. So beginning of isothermal is dito. 0.4 natin. That is IA. And then at the end of the isothermal expansion, that is 185. So P1 is 185. Ano pa? Ito. So determine natin A, the volume at the end of isothermal compression. End of isothermal compression. So dito yan, 0.3. Our lowest or lowest point ng volume. Okay, so how do we get that? We get first the volumes of the following points. So at point 1, gamitin ulit natin dito yung ating ideal gas, no? PVMRT. So at point 1, we have T. So V1. Hindi kasi given yung kumbaga expansion ratio. So kahit kunin lang natin is either 0.1 or 0.2. Nakuha natin V3 if given yung ratio. So V1 natin, that is MRT1 all over P1. Given tayo ng 2 pounds of mass ng air. Yes. Multiplied by R. Gas constant natin for English is 53.34 for air. Put on force. Put on mass runtime. Multiplied by our temperature 1. So at this point, it is the lower limit. So that's 70 plus 460. We will get 530 runtime. Cancel lang si runtime and on mass. Pang pressure pala. Pressure 1 natin, that is 185. So pound force. Which is squared. So gawin lang natin tong heat squared. Cancel ito. Cancel si h squared. Magiging cubic feet yung volume 1 natin. Okay. So paki-complete nga. Yung total is 53.34. Wala na ata kayo. So, sige. Let's try to tuloy na lang natin to sa next meeting after your quiz. Or maybe after your quiz. Kung may time pa. So, before I dismiss you guys, let me just check the attendance. Meron sa Kim, alam. Mr. Aquino,
Present, sir.
Arenas, okay. And para 2.122 po sa lesson guys. BI,
Present, sir.
Kagiwa, Castillo,
Present, sir.
De Luna, Estrada,
Present, sir.
Garcia, Idos, Pedrones,
Present, sir.
Parillo,
Present po.
Ravago, Sarmiento,
Present po, sir.
Saison, Serrano,
Present,
Sindayan, okay, Sindayan, and Tamayo.
Present, sir.
Yes, sir.
Yun lang muna.
Sir, hindi po ata ako natawag.
Sorry, ano. Oh, yes. Sorry, ano. Okay. Sige. Prepare for a quiz regarding thermodynamic process on Friday. Then let's try to continue this then Friday if kaya. 1 hour lang naman yung quiz. So kung may time pa, i-resolve natin itong problem. Hindi kaya, we will tackle this again next week. Okay. So, Amos Altini, the class is dismissed.
Thank you, sir.